Okay, so in mathematical tools, what we are going to cover? So we are going to cover in a lot detail trigo. We will be covering somewhat something called quadratic equation. I think in maths, you must be studying the coordinate geometry. Are you studying? I will be covering in that case basic of coordinate geometry. And at last, we will be covering the calculus. In calculus, we will have focus mainly on the integration and differentiation, maxima, minima. So we'll start with very basic of limits. We will not cover continuity because that's not required for physics point of view. And after limits, we can directly go to something called functions. In fact, we'll start with function first, then limit. Then we will go for derivation or derivative. So derivative, or you can say differentiation. And then we have maxima, minima, and then we go for integration. So, okay, of course, I will not go in deep in any of these topics because the whole idea is to make you just realize the basics so that you can use these ideas to understand physics very well. The deep knowledge will be imparted only in the math subject. Okay, so let's start with very basic called trigonometry. So if you just break this word into different parts, you can clearly see it's a tri plus gonal plus measurement. So the tri means basically three, and gonal means sides, and of course this is measurement. So this chapter is especially about the measurement pertaining to the three sides and of course three angles. So this chapter, or you can say this branch of mathematics, deals with sides of a triangle. I can say three sides and relation shape between sides and angle. So when you draw any triangle, A triangle is called the smallest polygon, right? So every triangle is the smallest polygon. And in a triangle, we have three vertex, A, B, and C. Let's name it. From the point of view of coordinate geometry, you can see it's an intersection of three lines, right? So the point A is the intersection of line, this and this line. The B is the intersection of this line and this line. And C is the intersection of this line and this line. So in different chapter, the perspective will change and the vertex becomes the point of intersection and the sides becomes a line. Okay, anyway. Now there are some conventions that one should be aware of, that the vertex A, so this is called angle A. We use this the inclined symbol for angle. So this we call angle B, and I hope you all know these are symbolic notations. And this we call angle C, and these are capital alphabets. A, B, C are capital uppercase letters. The side opposite to vertex A we call is small a. So this is the length of the side, and it's called small b, the length of the side, and this is called small c, the length of the side. So in most of the writing purposes, the angle we drop, we write the alphabet as the angle. So if I want to write only angle A, I will just write A. If there is an ambiguity, then we put this sign. If it is obvious that A represents angle, we can remove the sign. So that's not an issue. Okay. Now in triangle, the first thing that we need to understand is called the angle. Because if you see the word triangle itself is triangle. Okay, so we have three angles basically. So it is essential to understand what is the angle, and then probably we can deal with triangle. So what is angle? So of course, we have to define angle in two ways. Angle in a plane and angle in space. So the plane angle we just call angle, but angle in space we call solid angle. The way we measure the angle in a plane is called radian. I can put a different sign. So the unit of angle in a plane is radian. And what is the unit of angle in a space? What is the unit in solid? What is the unit of solid angle? I hope you know in class 9th or 10th you might have studied. Anyone?
Degree.
Pardon?
Degree.
No. So in international system of unit or SI system, what we study? So there are two types of supplementary units: angle of plane and angle of space, and it is called steradian, which we represent by SR. Okay. Now, if I ask you what is the angle in the plane, okay, so we'll stick to the two dimensions because every polygon which we draw will be in a plane. So we are not going to deal with the three-dimensional geometry, which is very complex. In three-dimensional geometry, the sum of the angle of a triangle may be 270 also, maybe 300 also. So your whole idea about the geometry is pertaining to the planar geometry, or you can call it Euclidean geometry. So geometry in a plane is called Euclidean geometry. So of course, it's not a geometry. It's a simple geometry which we know, and there is something called non-Euclidean geometry as well. So non-Euclidean geometry deals with geometry in higher dimension. So, okay, we will stick to the Euclidean geometry, the planar geometry, and we'll try to understand the definition in the same context. So, we'll not digress from the our present topic. And there is a whole world of non-Euclidean geometry. And of course, most of the NASA scientists, they use it a lot to understand the space time curvature of course, space. So Einstein actually gave the idea about the non-Euclidean geometry. So let's say if it is a source of light, and if this is you, we have no idea that how the light ray is coming. So let the light ray is going this way. Why? Because we have a somewhat black hole here. So imagine we have black hole here, and because it's a black hole, the light will bend. You know, black hole is so powerful it will bend the light. And the whole idea of straight line will disturb, right? So now the light always travels in a straight line, but is it a straight line? No. So when we deal with such kind of geometry, then it's basically non-Euclidean geometry. This is called the non-Euclidean geometry, okay? But anyway, that's not your uh, requirement. I can also show you that, okay, the sum of the angle of a triangle is how much? You know 180, I'll show you. It could be 270 also. So imagine there are 3 points on a giant sphere, as giant as you can think as a Earth. So if I tell you, okay, draw a straight line big enough, you will never realize that while drawing this straight line, you have bent over the surface. So you keep on drawing, but you actually turn around like this, isn't it? Which you don't realize. And then you draw again a line. Again, you don't realize that you have turned like this. It's a huge sphere. So for a person who's doing this triangle, it is still a triangle, but this triangle is not in a plane, right? You can clearly see this triangle is on a three-dimensional space on a sphere, and you can see the angle is how much? See, so sum of angle of a triangle is not necessarily be 180, but of course that's not planar geometry. That's not Euclidean geometry, and that's why these are some glimpses of the world that you will see as you grow old in your profession. At higher studies, someone interested in the cosmology or high energy physics research or quantum research, you will come across all this non-Euclidean thing. As of now, for JEE syllabus, we are very much happy with the Euclidean geometry. Our idea is based on that, and we should stick to that only. Okay. This is just a glimpse of non-Euclidean geometry. So I was talking about the angle. and especially the angle in a plane. Uh, okay, let's keep it 2D. So what is angle? How we define it?
The amount of rotation to move from one line to another.
Yeah, I mean, somewhat like that. Okay, we can just put in a better way. Like whenever two lines meet at a point, then the inclination between the line is called angle, right? It's inclination basically, isn't it?
Yeah.
So this is what I studied in class 9. That's what I remember. I don't know after ninth. Okay. So let me just put it that way. So when two lines or rays, you can say, meet at a point, then the inclination between them is called angles. Okay. So can we see angle? Can we see angle? Okay, tell me, can we see angle? Yes or no?
Yeah.
And how we can represent the angle? It is the inclination between the two lines. Okay. So you can perceive that angle. Okay. So you are saying, okay, you can perceive there is an inclination, but you cannot see the angle, right? You understand, okay, they are inclined. And that inclination idea we are trying to express to the world. And so we introduce something called angle. There is no way to represent it. I mean, I don't know how to represent it. But technically, people draw something like this and they call angle. But is it so? Is this angle? No. Is this angle? So which one is the right one? All are okay. See, this line you're drawing to tell to the world that, okay, I'm trying to find the angle between these two lines. But are we seeing it? Okay. The idea is we are just representing it. And how we represent it? So we call this as by some symbol. You just choose some symbol. You call it theta or whatever. So it is just an expression. But it will, I mean, the inclination is definitely not depending on the length of the line. If I make the line smaller, what will happen to the inclination? Will it change? Now, can we say the angle has changed? Yes or no?
No.
So, is there any impact of size of the ray or the line on the value of angle theta?
No.
It means angle theta has nothing to do with the dimension. So, every angle, because it does not depend on dimension, so it must be depending on some ratio, because ratios are dimensionless. If you divide two lengths, you will get zero dimension, no dimension. So angles are generally defined in terms of ratios, which is a logical way of representing. And by completing a triangle, the angle gets its meaning in multiple ways. So we have sine, cosine, cotangent, tangent, secant, cosecant, and so on. So all these geometrical definition we have put into some abbreviation, like we say SINE, the sine as sin, sin. The cosine, which is basically the meaning is complementary of sine, we call cos. Okay. Then we say tangent. So tangent line we call tan. And then we have the cotangent. So we say cot. We have secant. So we say sec. And then we have the cosecant, which is like complementary of secant. So we say cosec. Okay. Or like this. So angle is, of course, it's simply the inclination that the two lines produce when they meet at a point. The idea is how to express this idea of angle. So because inherently we know that it depends on some ratio, so we complete a triangle. So we simply complete a triangle. Now, no matter how big or how small you draw the triangle, the definition will not depend on the size. It will depend on the ratio. So some every ratio. So because the triangle is having three sides, so we are confused which three ratio we can take. Okay. So for three sides, a ratio we need only two objects. So we can use any two values, 3C2. Okay. So 3C2 will give you what? Three value. Okay, okay, sorry. Okay, you guys don't know what is 3C2. So if you have three objects to choose from, then how many pair we can make? 1, 2, or 1, 3, or 2, 3. So for three objects, we can make three different choices. So you have choice of either you choose 1 and 2, you choose 1, 3, you choose 2, 3. Because we're talking about the ratio, so we know that a ratio of A by B is not same as B by A. So for every pair, we have two ratios, right? So this will give you two values, this will give you two values, this will give you two values. So in total, how many ratios we can define? You can simply count 6, we can define. So that total 6 ratios possibly. So we have in total 6 ratios possible in, you can say, trigonometry. And based on these 6 ratios, for a right angle triangle, we have 6 different names actually. Okay, so these names are simply a symbolic. I mean, they have no meaning. I mean, it's just like when I say this, you should interpret this. When I say this, you should interpret this. So these are like naming given to the ratios. Okay. And it was like a convenient way of saying something. So then we came across something called a right angle triangle. Now, no matter whatever shape of triangle is given to you, you have the power to convert it into a right angle triangle, isn't it? So let's say if you draw some random triangle and you think, okay, you just draw a scalene triangle, imagine like this. Now, no matter what shape of triangle you draw, you always have the power to convert it into a right angle triangle by dropping some perpendicular from a vertex. So now this triangle and this triangle is separately right angle triangle. And because of the power of Pythagoras, we are truly comfortable with the right angle. Because most of the definition which came across, it came through the Pythagoras. So Pythagoras is the most fundamental theorem. And with the help of Pythagoras, we can prove any formula in trigonometry. So now we have a triangle, and we can call this inclination as angle. We can call this inclination as angle. We can call this inclination as angle. So we can see we have three angles. And because of the property that the sum of the angle is 180 in a triangle, and because one of them is 90, so the remaining two must add up to 90, isn't it? So we can say beta is nothing but 90 minus alpha, right?
Yeah.
Now, because the sum of the two angle is 90 degree, these two angles what we call? So alpha and beta are called complementary angle, right?
Yeah.
So if the sum of two angle is 90, we call complementary. If the sum of two angle is 180, what we call?
Supplementary angles.
Supplementary angles, right. Now, this idea of complementary angle is very, very again crucial when we solve physics in projectile motion. We'll come across this idea. So anyway, so in any right angle triangle, except the right angle, both angles are called complementary angles. Okay, and that's why the word complementary came into trigo also, and the complementary shrunk as a co, and then you say cosec, cos, or cos, cos. So this abbreviation came because of this use of complementary word, which we'll see in detail. But still, okay, in triangle we can take a ratios, and we define different types of ratios. There are 6 possibility of ratio, right? Still, I haven't defined what is angle. I'll come to the angle part. So out of these 3 possible angle, if one is 90, let me call this angle as theta. And for any given angle theta, the side which is opposite with what we call it perpendicular, and the side which is adjacent to the theta, what we call base, and the side which is opposite to the right angle, what we call hypotenuse, right? So we are very much familiar with these 3 terms, isn't it? And now every trigonometric ratio will be the ratio of pair of sides. So how many pairs we discussed? There are 3 pairs. And for every pair, we have a name. For every pair, we have a name. So the first is called sine of angle theta. Now, this way of writing is cumbersome, isn't it? So we wanted to write something simpler. So this transform into something called sin theta. It's like a language. It's nothing like you're writing multiplication. It's a sine of angle theta. How to read? Sine of angle theta. What is the sine value of angle theta? So sine in Hindi we call the Jia, which is again based on some mythological god, Jia, Vijaya, something like that. So in our Vedas also we have the explanation for sine. I have a book by Adi Shankaracharya, and he has explained about sine, cosine, and everything else in Sanskrit. Okay, nevertheless. So sine theta is a way to express or way to say what is the value of sine of angle theta. So it means I am pointing towards some specific ratio. And for the given triangle, let me draw the triangle again here so that you can see. So the sine theta is how we define? It is the opposite upon or you can say it is perpendicular. This is 90. Or because of the symbol which I have assigned here, we can write P by H, right? So this is the simple definition of sine of angle. So what is the cosine of angle? Okay. I'll let in detail. Complementary of sorry. Sine of complementary angle. So if this is the complementary angle, which is 91 theta. So what is the sine of complementary angle? If I choose this as theta, then the perpendicular will change. Now B becomes the perpendicular, isn't it?
Yeah.
Am I right? If I choose this angle to define sine, for this angle, the opposite is B, na? Correct? Hello, hello, hello.
Yes.
What is the opposite to this angle? The opposite side. It's B. Correct?
Yeah.
The opposite to theta was P. So the opposite to the complementary will be B. Okay. So this entire terminology we converted into some nice short notation. And now what we call cos of theta, or you can say cosine of theta. So this you can also call cosine of angle theta. You can just put it the way you want. And this will be definitely B by H, because the perpendicular has changed. For complementary angle, the other side will be the perpendicular, and that's logical. So now we have the cosine theta, and we call B by H. I hope this is clear and this is not difficult. And then we have something called tangent. So tangent is basically defined as the rise over run. So the general way of defining this, a rise over run. This is a very American way of explaining. So for angle theta, if you run by B distance, how much will rise? So this is the line. This is like say stair or maybe some elevator. So to rise by value P, how much you have to run? B value. So rise over run. So if someone is walking on this path, so this guy will rise as he will move. And what we can say that when he will move or to rise by P value, he must have the horizontal displacement, let's say in this case, B value. So the tangent is the rise over run. And that is what we always remember. We call it opposite upon base. But the rise over run is something more meaningful to me than writing P by B. So that's the tangent. And I think the cotangent will be obvious. What is the cotangent? You can understand. Like finding the tangent for the complementary angle, right? So in short, we write cot theta. So what do you expect, guys? The P and B will interchange? Yes or no?
Yes.
So can we write B upon P? Okay. And now comes the secant. Secant of angle theta. Okay. So how we write? SEC sec theta. So secant is a line which in geometry, what we call secant, a line which intersects a curve at least at 2 points, right? So if you have any curve and if a line is intersecting at minimum 2 points or more than 2 points, we call a secant line. Just from basic geometry. If we have any curve like this, let's say in a plane, and if this is a line, so at how many points it is intersecting? 1, 2, 3. It may be intersecting more. So if a minimum it intersects at 2 points, we call a secant line. And what is tangent? A line which only, you can say, intersect at 1 point or touches the curve just once. Okay. So this is called tangent line. So anyway, I mean, of course, the secant line and say the definition of sec is slightly different. So what is the sec of theta? How we define it? So you should also be aware that okay, sec of theta is basically inverse of cos, and this will become how much? H by B. And then what is left? 4 times cot is done, tan is done, cosec. The complementary of secant, cosecant. Cosec. And because it's complementary, so it will become H by basically B. P becomes. So we have this simple relation, and you know who is complementary of whom. So who is the complementary of sine? Cos. Complementary of tan. Tell me, guys. Complementary of tan is what?
What?
And complementary of sec?
Cosec.
Cosec. That's logical. I mean, who two? I mean, like you can always understand which two are related to each other by the complementary relation. Now, as a small, I mean, when we study in class 9th, I remember that there used to be some trick in the notebook, I mean, textbook to remember these relations, right? So I'll just put a sine theta equals to there are many, but I remember this one. I think this was in my textbook, which I forgot actually. It is like this. Some people have curly, I don't know, brown hair, totally painted black. So that time it was a big thing. Like, I mean, understanding sine cos tan was a really huge thing. So these the some tricks was given in the textbook. My teacher taught me something different. He taught me, and then he also taught me Pandit Badri Prasad Hari Bol. So it's various ways people have discovered the way to remember. I don't know was this required or not, but that's it's there actually. And you can see it's like the S represents sine, P by H. You can take the first alphabet, you get the answer. Cos, B by H, tan, P by B. That's simple and fair enough. And you can see P by H. Here you can see P by H, B by H, P by B. So you can remember the way you want. No need to get confused. Then I'll add the complementary, sorry, cosec. The inverse of sine is called cosec, which is H by P. The inverse of cos is called sec. And inverse of tan is called cot. And these are inverses. And therefore, if you multiply sine with cosec, you will get 1. Cos with sec, you will get 1. Tan with cot, you will get 1. So these are definitions. And that's why if you remember the first 3, The rest you can find by inverting it, right? So what we have is, we have the very famous Pythagoras theorem. So from Pythagoras theorem, so in a right angle triangle, what we can write? P square plus B square equals to H square, right? I hope you all know this one. Now this can be written in multiple ways because we have three terms. So how many possibilities are there? I can write like this. Can I write like this? P square equals to H square minus B square, or B square equals to H square minus P square, correct? And these three way of writing will lead to the three different identities in trigonometry. So I can divide by H square. Well, what I can get is P by H whole square plus B by H whole square equals to 1. If I divide by P square, you will get 1 equals to H by P whole square minus B by P whole square. And if I do the same thing, if I divide by B square, I'll get H by B whole square minus P by B whole square. And now we just learned the name of the ratios. Okay. So tell me guys, what is the P by H? What do we call this ratio? Tell me. P by H, perpendicular upon hypotenuse. What we call? Hello, hello, hello. 1, 2, 3. Am I audible? Sine theta. So this is called sine square theta plus cos square theta equals to 1. So now this is a very famous identity which we know. Okay, so basically it's the Pythagoras theorem, right, written in a nice way. You can say this is basically Pythagoras theorem. So we have only one theorem, Pythagoras, which leads to the various relation in trigonometry. So how to understand this one? H by P, it's like a inverse of sine. What do we call? Cosec square theta. Now this is how we write the square. The square term is written before, then we write the theta. And minus, what is B by P? B by P we write as cot, right? Equals to 1. So now similarly, can you tell me what is this? H by B? Anyone who remember this? H by B? Okay, what is B by H? Base upon hypotenuse? Come on, guys, tell me at least this.
H by B sec.
B by H is cos, I'm saying.
Yeah, so B by H is cos, so the inverse will be sec. So if this is theta, this is perpendicular, this is base, this is hypotenuse. So this is actually sec square theta minus tan square theta, right? So there are various ways in which the Pythagoras can be written, and so the Pythagoras has led to the three different trigonometrical identities. So these are called trigonometrical identities. And all are same thing. I mean, all are representing the same thing. Just the way we are putting in different ratio, of course, it will be different. So depending on what we choose, we have three possibility and we have three identities. So this is the first thing in trigonometry. This is called trigonometric identities. So what is the identities? In maths, what is identity? Identity versus equation. So what is the basic difference between these two terminology? Anyone?
So may I?
Yes, please.
Identity holds true for every possible value, while equation may not necessarily give all possible values.
Correct. So that's correct. I mean, identity is true for any value of variable, whereas the equation is true only for either some value or no value. Okay. For example, why I said no value. So if I say x square is less than 0, will there be any solution in the real world? The answer is no, because the square of a number cannot be negative. So no solution. Okay. Anyway, equation means the word equation has come from the word equate. So when you equate to something, we call equation. When you don't equate to something, we don't say equation. So these are identities, which means these are always true for any value of theta. So theta is the variable. Okay, so now I'm interested in the angle part. Okay, so the Pythagoras is done. Let's just do it quickly. Angle part. So angle definition came from the circle. So in every circle, now the question is, can we draw a circle? Kind of no, but for purpose, yes. So you may be thinking that this is a circle you have drawn. No, no, I haven't drawn. If you zoom it, you will see something like this in pixels, right? It's just like the resolution is so high that you don't see those blurriness. So computer always draws the zigzag path like this, and it becomes so small that you don't see these changes. So the entire screen is divided into pixels, right? And you can see the pixels. If you want to see, you can see. Okay, I'll try to do this. So you can see there's a curvature always. If you zoom, you can understand this is a zigzag path. If you watch it closely, it's very much zigzag, right? Anyway, the whole idea is a circle is a very unique construct in which we have something called diameter and we have something called circumference. So what is interesting that the ratio of these two is always a constant. So ratio of circumference to diameter is always a constant quantity and this quantity was vaguely known to the oldest mathematician, maybe from before the Pythagoras, maybe I think Archimedes and before that also. So this ratio was very much known to the world, but not exactly. And that was the detrimental to drawing the circle. Because it is found to be constant. Roughly, this idea was there inherently with the mathematician that this ratio is always a constant quantity. But how much? So till date, we never know the exact value. But now, this inexact value, what we call? So we call this as pi symbol. Pi is like some value which we don't know. So let's give a symbol to it. So we call this pi. So pi is defined as the ratio of circumference upon diameter. This ratio is called pi, and because it's a ratio, and this ratio is still till date not exactly known. So this is the irrational number. Irrational. Up to 4 decimal place, this value we have figured out is 3.1415. Now you may be wondering why this is so important, like 1.1415 is sufficient. The answer is no, it is not sufficient. Because when we go for the space exploration, there we have to travel lakhs of miles. And a decimal place is so significant that when you multiply 3.14 by 1 lakh, let's keep it simple, let's say make it 10 lakh. And if you multiply 3.1415 with 10 lakh, can you guess the change in the answer? Let's say this is kilometer. So how many extra kilometers the spaceship has to travel? And you can understand it's a huge number, right? It's not very small number. So we need more and more decimal accuracy, maybe up to 100 points of decimal. Okay. And that's why the world was curious about pi for a very long time. Now, through various definition of mathematics, we know the value of pi up to more than 1,000 or more than that number of places of decimal. And with progress in mathematics and science, we are able to achieve more accurate answer about pi. Okay, you may be wondering what is so accurate. We can keep on dividing. It's not possible to keep on dividing even manually. So we have computer generated values, because if you keep on dividing, what you're getting may not be accurate. Okay. So this ratio we determine experimentally through various heuristics in mathematics. And it is of great importance. I mean, of course, the pi is not something as simple as you understand 22 by 7 or 355 by 113. No, it's not like that. It is much more deeper than what we can realize as of now. So this ratio is still not known. I would say dot, dot, dot. I don't know the exact answer. And just to capture the essence of this inexactness, we have designed a symbol, a Greek alphabet, pi. Okay. And this pi we call C by D. Therefore, the definition of circumference is what? Pi D. And D is, you can say, twice of radius. So we can also say circumference is 2 pi r. Correct? These are various ways of writing. So the angle is the ratio of circumference upon diameter. It's a pi angle. So if I choose in a circle, again, angle is a ratio. Do you remember this? Angle is a ratio. And sine and cosine or tan, all these are angle only. I mean, sine of angle is, again, it's a ratio only. And when we put sine, cos, and tan, we actually mean to say that take the ratio of these two sides. If you want to understand the angle only, not the sine of angle, just angle, then we have to draw a circle. That's a basic fundamental rule. And in this circle, as you move along the curve, so what we do is called arc length, right? I hope you have heard this word. This is called the arc length. A general way to understand the arc length is, we represent V is L. We just call it L. It's the arc length. And the radius is R. So the sine cos tan is the ratio of sides in a right angle triangle. But angle is simply the ratio of these arc length and the radius. So this angle in radian, the angle, and of course this is pi radian. You can write like this. C, the power C means radian. So the angle in radian we write with symbol theta. And this is again a ratio of arc length upon radius. And therefore theta we write as L upon R. Now at the same time, you can also understand a lot of things. That I can also draw a triangle in that circle itself. And I can call this as, let's call it what? P. What is sine of angle? Tell me, guys. What is sine of angle? Can we say P by R?
Yeah.
And you can clearly see which one is bigger. Sine of angle or angle itself. Both are ratios. But which ratio is bigger value? The arc length is definitely bigger than P, isn't it?
Yeah.
That's common sense. No? Arc length is bigger than P. Yes or no?
Yes.
So we can clearly see that theta is always bigger than sine of theta. So sine of angle is less than angle itself, because both are representing a ratio, one in a circle and other in a triangle. And by drawing both in the same diagram, we'll give you the right idea that how to interpret the sine of angle and angle. And always remember the angle represents ratio of two length. And in different contexts, we name it sine, cos, tan, and so on. So the sine of angle and the angle are closely related, and sine of angle is less than the angle. I hope this is clear. No. Yes. Not clear? Hello, hello, hello.
So clear.
The second thing is, under what special condition they may be equal? That's common sense. What is the common sense? As I decrease the theta, the difference will kind of compensate, isn't it? Or will diminish. And everything comes from the triangle, I mean, this circle only. The concept of limit will come from here only. So the moment you draw a circle and the moment you try to express angle, and we have the right angle triangle here. Clearly for this big angle, this length and the arc length are quite different. In fact, the difference is significantly visible to us, right? That out of P and L is much bigger, you can see clearly. But what if we try to decrease the angle? If I try to decrease the angle and if I draw a new triangle like this, and if I call this as, let's say, alpha, you can see the perpendicular and the arc length, the new arc length, are they differing by large value or small value? Now, tell me. The difference has decreased, no?
Yes.
Between the arc length and between the perpendicular. Do you realize this? I mean, this is very important. This is the crucial part that you should understand in mathematics. And basically, it's a common sense. I mean, I won't say you need to know mathematics to understand these things. Do you realize that alpha will decrease, then the difference will converge towards each other? Anyone who is able to realize this?
Yes.
Siddhant, are you getting it?
Yes, I'm getting.
So now imagine a situation. What if the angle is almost tending to nothing? Imagine this is the line. And what if I take the next line almost like this? Just a minute. If I have a triangle like this, and let's say you draw a perpendicular, you know, if angle is really small, if this angle is as good as nothing, but not nothing. So how we express this emotion? That something is very small, but not, something is almost zero, but not zero. How we represent? There's a way of representing. So we say the angle theta is tending to zero. which is quite different from equals to 0. So what's the difference? This representing exactness, and this is approximation. So if I ask you the idea of theta tending to 0, it's like asking which number comes after 0. Tell me. Which number comes after 0?
We'll find it.
Can we say it? Is it possible to say the number next to 0?
No, sir, we can't see. We can't
We
express.
can't say. But we know it's there. There must be some number next to 0, yes or no?
Yes, sir.
But can we say it? Can we say it?
No, sir.
No. It is exactly like a God. Everyone knows it's there. We can't see it. See how powerful is maths and spirituality. The number next to any number is there, and there is no way to express it. The same dilemma was faced by Newton, so he created the entire concept. So he, in fact, he made the entire God as a symbol. And when this God came to us as a symbol, what we called differentiation. So I'll come to that. And that's very nice philosophical bending you will see. So theta tending to 0 is a way to say that I'm just interested in the number next to 0, which is as good as 0 but not 0. Quite philosophical. So it is almost 0, as good as 0 but not 0. And there is a huge difference between when I say something which is as good as 0 and exactly 0. Let me show you the meaning of it. Imagine this is a disk, okay, and you divide by a tiny disk. What is the meaning of division, guys? Division means how many dot I must replicate to create this much area, isn't it? So it's a count of the dot, right? You count the number of denominator which can create the numerator, isn't it?
Yes, sir.
Now imagine if I shrink the size of the dot, the number will increase or decrease.
Increase.
And if the size of the dot is tending to 0, the number will become almost infinite. So can we say when a number is divided by another number which is tending to 0, and then assuming C is positive. So let's say we have a constant which is positive is divided by a number which is almost 0. This will tend to infinity. Understood? Now this infinity is actually huge value, large value. This infinity is representing large value. A value which is really, 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 really large. Now imagine the situation. I have a disk and here I divide by nothing. So there is nothing which you can replicate. Will I ever be able to get this? See, when you divide something, you have to have some size so that you can replicate to get it. But what if there is exact 0, nothingness? If we have nothing here, can we achieve this disk now? So we have nothing to replicate. Can we ever, no matter how many times you multiply nothing, will you get something? So no matter how many times you multiply a 0, will you get any number? The answer is no. 0 into anything is only 0, isn't it? So can we say this as infinity? The answer is no. What do we call this? Undefined. So something as good as 0 is defined, but something exactly 0 is undefined. Do you realize the difference between these two? Nothing cannot create something, but something which is very small can create something very large. I just need to replicate more number of times. That's it. So in mathematics, the concept of infinity and concept of undefined are so intermingled that it's a very fine line. You need to understand the fine line where it is not defined and where it is large or infinite. So infinity and undefined goes hand in hand, and the meaning will change as we change the context. So now coming to this relation, if theta is tending to 0, what you can realize, guys? Do you realize that the perpendicular and the L both are matching? Can we say this? Yes or no?
Yes, sir.
So can we say theta, which was earlier less than sine theta, when the limiting case is theta tending to 0, the theta will be closely equals to sine theta? Can we say? Yes or no?
Yeah.
So for a small angle, can we equate these two answers? So when the condition is, when we say in the condition when the angle is tending to 0, you can always write sine of angle as simply angle. Do you realize this relation? Yes or no? Is this clear, guys?
Yes,
Tell
sir.
me. Hmm?
Yes, sir.
And that's very beautiful. I mean, that's very beautiful. So you can see, if you talk about the cosine, I mean, that's very interesting. You can always understand this thing. What is the definition of cosine? If you remember, base upon hypotenuse, correct? Yes or no?
Yes.
Tell me, guys. So as the theta will tend to 0, do you realize the base is same as the radius? Can you see it? Both are almost same. The hypotenuse and the base, is there any difference?
Yes, sir.
Both are almost equal. Yes or no?
Yes.
And when theta will be exactly 0, the base and radius will be same, exactly same. So what we expect the cos of 0 value? One. Yes or no? How many of you are able to realize that cos of 0 is 1?
Yes,
Yes.
I got it.
Yes.
Got it? So cos of 0 is 1. Why? Because by the way we define it, the base upon hypotenuse, and from the circle concept, you can clearly see that as the theta will tend to 0, definitely the base and radius will be similar. I mean, there is no apparent difference between the two. And therefore the ratio becomes 1. And at the same time, what is sine of 0? You can realize from here when theta is 0. So what is sine of 0? You can see it is perpendicular upon hypotenuse, but the perpendicular length is almost shrinking to 0, isn't it? So when theta will be exactly 0, the perpendicular becomes how much?
0.
Upon hypotenuse will be 0 only. And that's the logical answer. That sine of 0 is 0. That's logical. In fact, for a small angle, we have just realized that sine of angle is angle if angle is really small. So sine of 0 is exactly 0, but sine of a small angle is the angle by definition. And these ideas will help you in understanding the concept of limits. The limit means as some number goes to a desired value, how the behavior, the mathematical behavior changes. Okay. So theta is a ratio, sine theta is another ratio, but they are different in general. And theta is, oh, my bad, I made a mistake here. Theta was more than theta, no? Just a minute. So theta is bigger than theta, sin theta, right? Correct. So in general, angle is more than sine of angle, that we have realized. But under the limiting condition, what happens? When angle becomes really small, these two values will be same. And how to remember this? You have to somehow imagine this picture in your brain while solving the question. You have to imagine this picture. You have to imagine this picture. And if you can imagine this picture, everything will be quite visible to you. You can really understand what is the definition of theta. So the definition of theta is the ratio of arc length upon radius. But the definition of sine, cosine, or something called trigonometric ratios. So the trigonometric ratios are different from the definition of angle. So trigonometric ratios are meant for the right angle triangle, whereas the definition of theta is meant for the circle. Is this clear? And therefore, whenever you want to compare these two quantities, which are again ratio, so sine of angle and angle, cos of angle or angle, all represents ratio, but there is a subtle difference. That difference you have to keep in mind. And if you keep that difference in mind, you will be very much easily able to translate the mathematical expression into something interesting. So when you will study mathematics, these things will help you tremendously, that how to interpret angle in a right way. Most of us are not aware of this fact, that how to interpret angle itself. Okay. So what do we think angle as? Some formula, 30 degrees, 60 degrees. No, those are not angle. Those are simple division. It's like various number system we have. So we have decimal system in which we have 1 radian, like you can say pi radian we define as a in 100 equal parts. So in various system we have different number of divisions, and based on those number of divisions we have degrees defined. So degree is not a measurement. Degree is a way to represent. Okay. So when we say angle measurement, it is radian. When we say angle representation, it could be radian and it could be degree. So please be careful about the difference actually. Representation and measurement are two different things, right? I hope you're getting my point. The degree is not the measurement, degree is the what? Representation. And what is the relation between these two representations? I hope you know the relation. So what we say, the pi radian can also express as 180 division or degree. Okay. So what is the equivalent value of 1 degree? 1 degree is how much? 1 degree is equivalent of pi upon 180 radian. And radian is a number. When I say radian, it's a number. Degree is not a number. Degree is some sort of representation. So what is x degree? Equals to pi by 180 into x radian. Correct? Hello guys, tell me. Are you getting it?
Yes, sir.
Yes, sir.
So now if someone will say what is 90 degree, you can put the value 90 in the formula. You can write pi by 180 into 90, which is pi by 2 radian. Common sense. Because pi represents 180 degrees, so 90 will be half. So what is 45 degree, guys? Pi by 4.
5/4.
What is 60 degree? Pi by 3 radian. Correct? What is 30 degree then? Tell me quickly. Tell me.
5 by 6.
5 by 6. Very good. What is 120 degree, guys? Tell me quickly.
2 pi by 3.
Very good. So if you have degree representation given to you, you must convert into radian when you do mathematical calculation. Okay. So degree is the representation, not the measurement. Measurement is radian. Okay. And these are some having equivalence. So how to find these common values? Let's say I want to know the 30-degree or 60-degree. How to get what is sine 30? How to get it? So it's a ratio. So what we'll do is we'll just make some smart, intelligent triangle and we'll get the answer. So we know that we have something called equilateral triangle. So what is the property of equilateral triangle? Anyone? All sides will be same, and therefore we can say all angles will be equal. So every angle will represent how much?
60 degrees.
That's common sense. And what if I draw a perpendicular from vertex to the base? This will create a right angle triangle for us, which base becomes a by 2 like this, isn't it? So if this
Yes,
is
sir.
a by 2 and this is a, can we find the height, this vertical height? That's easy. We can use Pythagoras. So from Pythagoras, we can write a square equals to p square plus a square by 4. Yes or no? Tell me quickly.
Yes, sir.
So what is p square, guys? A square minus a square by 4, which is how much? 3a square by 4. So what is p value? Root 3a by 2. Yes or no? And because this is the perpendicular in a equilateral triangle, can we say this is the angle bisector also? This is 30. This is 30. Yes or no? Tell me,
Yes.
come on, guys. So if you want to find any value, let's say you are interested in sine 30. So what you are trying to say, sine of angle 30, which is by definition opposite to 30. Which ratio? This is the ratio of side opposite to 30 and hypotenuse. Can you tell me what is the answer? By looking at the triangle, not what you know the answer. So sine of 30 will be how much? A by 2 by a. Do you realize this? Hello, hello.
Yes, sir.
And therefore you can see the answer is 1 by 2. I am proving the value that sine 30 is 1 by 2. We can do it by simple geometrical construct. So sine 30 is 1 by 2. Now, if someone is asking you to find cos 30, you can see the triangle, you can tell me the answer. So what is cos 30, guys? Tell me. Cos 30 is how much?
So P by A.
P by A. Very good. And you can see clearly P by A is root 3 by 2. We have done this here. Correct? And any value you want, you can find the value. So what about the tan 30? What is tan 30?
A by 2 by P.
A by 2 by P. Very good. Which is like A by 2P. And A by 2P is, we know. So 1 by 2 into A by 2P. Sorry, A by P is inverse, 2 by root 3. So tan of angle 30 turns out to be 1 by root 3. Do you realize this? See, we are not trying to mug up the answer. We are trying to derive from the definition that how the ratio lead to the various answer. So can you do the same thing for 60 degree? I think it's fair enough. It's easy enough. Just see the triangle and keep on writing. So what is sine 60? Complementary values will give you same answer. So sine 60 is as good as cos 30. Understood? Because these two are complementary. So what is the complementary of sine?
Cos.
So sine 30 will have cos 60. So the value of sin 30 will be same as cos 60. The value of cos 30 will be same as sin 60 and so on. So the value of tan 30 will be same as cos 60. Complementary. And also from the definition of a ratio, this triangle will give you a lot of answer. So when we want to find the 30-60 relation, the equilateral will help. Okay. To get the 45-degree relation, which kind of triangle we should draw?
Right angle isosceles.
Very good. So we must draw the right angle isosceles triangle. And that will give you the logical answer. You can always draw in your mind and you can understand how it will look like. Now, of course, see, we are not trying to learn the sine, cos, and tan. This is something which you must be knowing, or you have the idea. Try to understand the underlying geometry, how we use geometry to our advantage. It doesn't look equal. So now if it is a isosceles right angle triangle, if I say this is A, from Pythagoras, this will be how much? What is the value of hypotenuse?
Root 2e.
Root 2. Very good. So now I think everything is obvious. Sine 45 will be how much? By definition?
A by root 2a. So that will be 1 by root 2.
Correct. Very good. So it's a 1 by root 2. And again, because all angles are same, so complementary will give you same as this. So this is also same for cos, right? So it really doesn't matter whether you look from this side or this side. You will end up looking at the same triangle. So that's why in 45-degree triangle, the sine cosine will be same. The tan cot will be same. Correct. What is tan theta, by the way? What is tan 45? The rise over run. And you can see it's a very simple. The rise is same, the run is same. By definition, A by A, which is how much? 1. So anyway, we know that tan 45 is 1. It's very famous answer. Correct? Hello, hello.
Yes, sir.
Yes, sir.
And now how to interpret the obtuse angle? I mean, how to say that, okay, to deal with obtuse angle? If we have an obtuse angle, the triangle won't be right angle, but we can make it. So imagine if I'm drawing something like this. And imagine this is how much? 60 degree. So this is 120 now. Okay. Then how to convert this into a desirable triangle? So let's say if I choose this as A, this as A. So this will be this angle must be same as this angle, because in a triangle, the angle opposite to the equal sides will be also equal. If you remember this theorem from basic geometry in class 9th. In any triangle, if the sides are opposite sides are equal, then their corresponding angle will be also equal. So if this is theta, this must be theta. Do you realize this?
Yeah.
Because I have taken A and A. And therefore, the theta plus 120 turns out to be how much? 180 degree. So 2 theta is 60 degree. So the theta is 30 degree. Do you realize this? Maybe. And then you can write this as the triangle. This is the triangle. And again, if you know the resolution of vector idea, if this is A, this is 60 degree, this will be how much? This will be How much?
That angle will be 30 degrees.
It will be A cos 60, right? A cos 60. It is like projection, na? If you remember, it is like projection. Yes or no?
Yes, sir.
Yes.
And this will be like, if it is a cosine projection, this will be the sine projection, A sine 60. Okay. So these are like projection. Okay. Now the question is, can we find the obtuse angle? And if yes, then how? Okay. How we can find the obtuse angle? So in obtuse angle, of course, we only find for the right angle triangle, and obtuse angle is not right angle. Okay. So what is this value? This value becomes A by 2. A cos 60 is A by 2, if you remember. And this will become root 3 A by 2, because now we have understood that sine 60 is root 3 by 2. Okay. So let's say I'm interested in finding the sine 120 degree. The problem is I cannot see the right angle triangle. So how I'm going to express the opposite upon the hypotenuse? It's not possible for me. So we always find the complementary part. So what we do is, because it's difficult, so in Trigo, which I will give you in detail, we always convert something like 90 plus 30 degree. So we can add 120 degree as 90 plus 30 degree. So it is beyond 90. And then we have some relation that when sine is 90 plus some angle, it is actually same as sine 30. And then again, we can go back to sine 30 to find the answer. We know how to find sine 30. Okay. Every angle which is not acute, we use some transformation rule, which I will teach you today only, hopefully. And using that transformation rule, you can find sine, cos, tan of any angle in the world, any angle, 1000 degree, 2000 degree, and so on. So anyway, you are supposed to remember only the basic one. Now, the other question is like how to deal with, because see, these geometrical constructs are good for simple angle, like maybe 15 degree, 30 degree, 60 degree, and so on. But let's say if someone is interested in finding the value of sine 31 degree, now I cannot draw any triangle in which I can find 30 degree, 31 degree. It will be really difficult. But fortunately, you can say, we have something very alternative available in mathematics, which can give us the way to compute these values with ease. And these are called series expansion. So we have something called series expansion. We say that if you have sine of x, where x is in radian, then every trigonometric function can be expressed as sum of polynomial functions. So we can write this as x minus x square by 2 plus x cube by, I think, factorial 2, factorial 3, and power 4 by factorial 4, and so on. Up to, there are infinite terms. It will never end. Okay. It will keep on happening. It can keep on acting. So these terms, the sine x, cos x, tan x, in mathematics, these are beautiful series expansion, what we call series expansion, which converts every mathematical non-polynomial function into a polynomial function. And we can deal with polynomial function, and the number of terms which you will take will decide the accuracy of your answer. And if you're satisfied with the accuracy, you can only keep those many terms, because it is infinite term, it will never end. So we generally keep one, two, or like minimum 2 to 3 terms to get the desired answer. Understood? So this is again a powerful method of dealing with trigonometric ratio, which is not possible through simple geometry. So we go back to the polynomial notation, and using that polynomial notation, we get the answer. So of course, you will come to know about this series expansion. You will get a basic idea in chapter of limits, or maybe at the end of class 12 mathematics called expansion. And we have something called Taylor series, Maclaurin series, which gives these ideas. And to grab those ideas, you have to study the calculus in detail. So after learning calculus, you will come back to these ideas. I'm giving you just hint of everything, like how the world of mathematics works and why these things are introduced and what are their correlation and how to go about it. Okay, so what relates what, and when in what situation we need different way of writing. Okay, so although we started with the sine and cosine as a ratio, now we are saying that okay, it's a polynomial. So of course, we are going much deeper into a different realm of mathematics. We need to use all of these up to very certain extent in physics. But you need to know that physics is going to use everything without worrying about what math has taught you. And that's why my job is to give you the glimpse of mathematics that physics need here and there all the time. Okay. So I hope you got a basic idea about the trigonometric ratios, correct? So you can make a table of this. We have something really interesting angle, which is I'm particularly interested in, called 37 degree and 53 degree. So this is very famous, and this can be achieved roughly by drawing a very nice triangle called 3-4-5 triangle. So you can see clearly the 3-4-5 represents Pythagorean triplet, isn't it? 3 square plus 4 square is 5 square. Do you realize this? And because 3 square plus 4 square is 5 square, can we say this is Pythagorean triplet? Yes or no?
Yeah.
So we can always write, draw this, triplet, and you can clearly see 3 being the smallest side, 4 larger side, and the 5 the largest side. So if I call this as 3, this is 4, and therefore this is 5. Now common sense, if one of them is 37, then which one is 37? Can you guess? The top or the bottom? This or this? So 37 is less than 53. So which angle is 37? Upper one or the lower one?
Lower.
So this looks 37. And this looks 53. Come on. Okay, you don't see the inclination. Which inclination is more?
Achha, got it, yeah.
So the dimension is given at 3, 4, 5. So definitely this is going to be small value. The inclination is,
Yeah, it's
see,
smaller.
if you can see, if you run by 4, it will rise by 3. But for this angle, if you run by 3, you will rise by 4. So which one is bigger? Definitely the anyway. So this is 53 degree. And the moment you draw this triangle, you can answer all questions. What is sine 37, guys? Tell me. What is sine 37?
3/5.
3 by 5. What is cos 37? See, you have to picture this triangle in your brain. Then only you can answer. You cannot mug up all this.
4/5.
because if you mug up, you will get confused. And what is tan 37?
3 by
3 by
4.
Similarly, what is sin 53?
4 by 5.
And what is, okay, then cos 53? And what is tan 53?
4 by 3.
So you have to remember this triangle somehow. And then you get the answer without putting pressure on your brain to remember the value that sin is this, that is that. No. So I hope the angle part is clear. Okay. Now some basic practice, very simple and basic practice about maths. So let's say if I tell you that sine of some angle is a ratio like 4 by 7, just random value. So given this ratio, what is the cos of the same angle? What is tan of the same angle? Tell me. So given sine, can we find cos or any other ratio? If I know one ratio in a triangle, that should be sufficient to get any other ratio, isn't it?
Yeah.
So if sine is given, what will be cos? So the very simple, you can use the identities. So we know sine and cos relation already. Sine square theta plus cos square theta is equals to how much? 1. And therefore we can say cos square theta will be how much, guys? And therefore the cos theta will be, we are taking the positive value. 1 minus 4 by 7 whole square under root. So the answer is how much? 49 minus 16 upon 7 square will become 7. I'm taking it out. So this is how much? 3 and 3. Now, if I have to find only one value, this is okay. But what I prefer, the moment a ratio is given to you, you can draw a triangle, any triangle, just draw a triangle. Draw the angle theta. So as per definition, sin theta will be opposite upon hypotenuse. So even if I draw a triangle like this, that's okay, sufficient. And the moment we have the two sides, we can find the third side using the Pythagoras, which is 7 square minus 4 square, which is how much? Root 33. So always make sure that you draw a triangle quickly and find the missing value. And once you find the missing value, the other ratio you can quickly express by looking at the triangle. No need to do this calculation again. So what is cos theta? You can clearly see it's the base upon. What is tan theta? Or for that matter, if I ask you what is sec of theta? So no need to look for the identity and get the answer. You can get it directly. Okay. So what is sec theta?
7 by root 33.
Yeah, wait. 7 by. So any angle given to you, once you know one angle, draw the triangle quickly and go back to the relation. Some really interesting stuff that you will come across in mathematics a lot, and this will help you that time. So let's say if I give you a question like, let's say sec theta and tan theta, if this is equals to let's say P. P is some number. And then someone is asking you find sin theta. And this question is based on the trigonometric identities. Can you get the answer? Can you think of getting the answer, please?
Yes, sir.
Okay, try this out.
Yes, sir, I think I got it.
Yeah, tell me.
P cos theta minus 1.
The theta cannot be in terms of theta. The answer must be only in terms of P. The answer should have only P term, right? The number is P, na? So I'm what I'm writing here is I'm writing the two ratios, and if the two different ratios add up to P value, then what is the sign of the angle? Like one of the other ratio I'm asking. Given the sum of two ratio, can you find the third ratio? I mean something other ratio. Okay. So it's not very difficult. So the ratio that we use to solve question like this is the sec square theta minus tan square theta equals to 1, right? It is like a square minus b square equals to 1, correct? And we know how to write a minus b into a plus b will be 1. Therefore, any term will be the inverse of the other term, or a plus b will be inverse of the. So this is a beautiful relation that given this p, because sec of theta plus tan of theta is given as p, the difference will be how much? Can you guess?
1 by
1 by p, it's simple, it's inverse.
Yeah.
And therefore, if I add these two equations, I can get the sec one first. So 2 sec theta equals to p plus 1 by p, which is like a p square plus 1 by p. And yeah, so I can add sec theta equals to p square plus 1 by 2p. So I can invert it. So cos theta is how much? It's the inverse of this. 2p upon p square plus 1. And because we know cos theta, we can quickly draw the triangle. And we can call one as theta. What is cos theta? The base, you can see the base upon hypotenuse, right? So what is the missing part? Under root of? Correct? Yes or no? So this is p power 4. I can add like a square minus b square. So a plus b into a minus b. Which is like it is p plus 1 whole square into p minus 1 whole square under root. Correct? And therefore it will become, let's say p is more than 1. So this is p square minus 1. So that's very interesting that this term is actually equals to p square minus 1. Let's say p is more than 1. We can think that. So what we can say here, or you can put a mod sign because we don't know which one is bigger. So mod is better. So I was asking what value? Sin theta. And now looking at the triangle, can you say sin theta? What is sin theta? Tell me, guys. Sin of theta is how much?
Mod p square minus 1 divided by p square plus.
Now, these are called manipulation. Like in the trigonometric identities, there are two such manipulation. One is the secant tan, other is the cosecant cot, because both comes with minus 1. And both follows the same relation, a square minus b square equals to 1. And therefore, the difference and the sum are always inverse of each other. And now that's the beauty of mathematics, that you know these inherent relation and then you put that into use to get the answer. So just solve one quickly question. So one quick question will be, yeah, fine. So cosec theta minus cot theta turns out to be 2. Find cos theta. Can you try this now?
Sir, I got the answer.
Okay, very good. How much?
3/5.
3/5. Nice. So, okay, so it means it's a cos of 53 degree, right?
Yes.
Anybody else getting the answer?
Yes, the same.
Very good. So the cosec theta minus cos theta, cot theta is 2. So cosec theta plus cot will be how much? 1/2, right? And then you can simply add these two to get the 2 cosec theta is 5/2. So cosec theta is 5/4. So sin theta is 4/5. That's pretty easy. Okay, so what I'm asking, cos theta, which is 3/5, is the correct answer. Very good. Okay, so after learning this, the use of trigonometric identity to in various situations. See, for sine cos, we always use the 1 minus cos correlation very quickly. That's easy. Many cases, you draw a triangle and you get other relation. And with time, you have to learn the manipulation of various ratio. And what I'll say is that once I'll finish the trigo part, you should finish the trigo from math book completely. So you will be able to finish your almost 50-60% of mathematics. Trigo with ease, it's pretty easy. NCRT shows you can finish everything. And if you want to go deeper into Trigo, I will suggest that buy book by SL Loan for Trigo. Okay. So there's a book of trigonometry by SL Loan. It will cost you 50 to 70 rupees something. And then you can go chapter by chapter and you can keep on solving. It's really very much organized. And this is for the JEE syllabus. In my time, we studied in class 9th and 10th. This was in a class 9th and 10th recommended book for us. So Trigo was, because I read in class 9th and it was easy. So if you study from now onwards on a day-to-day basis, your Trigo will become really good. And what is the benefit of having very good Trigo? You will become powerful in integration. So people find integration very difficult because they have less exposure to the Trigo actually. And Trigo gives you the ability to manipulate various sine, cosine, sec, cot, and so on. So be good with it and start practicing from now. Don't wait for the class 12 syllabus of trigonometry and then you will study. That's not the way to go ahead. Okay. So now we can go to the angle part again. So I'll put on next page. So we have something called SIGN, sign of trigonometric ratios. Trigonometric let's say we have a coordinate system. A Cartesian system. And if we draw any line, first of all, we need to understand, if we draw any line, the angle we always measure with respect to the inclination with the positive x-axis. Now, this is my positive x-axis, and we always check the inclination with that axis to understand the angle. So this is my angle. And the measurement we go from the axis towards the line, not the vice versa. So there's a sense of rotation also. So we always move, as you can see, anti-clockwise, and that is how we measure the angle theta. If I draw a line somewhere here, so my angle measurement will be like this. But it is not only limited to that. In Cartesian system, if the angle will exceed 360, then you repeat the rotation. So in Cartesian system, the angle need not to be only between 0 to 360, but it can be any angle. The good thing is if we have bigger angle, it will keep on rotating like this. So this angle is how much? You can say, let's say, if I draw a line somewhere here, so that's where the angle is ending. And if I call this part as alpha, can you guys tell me what is the angle? Anyone? How many rotation? Hello, hello. Am I audible, guys?
Yeah. I
How
think
many?
4 rotations.
So 1, 2, 3, 3 rotation, right? Complete.
Yeah, complete 3 rotations and the fourth one is kind of semi.
1, I'll just change the color to understand. 2 and 3. So we have 3 complete rotations. So 3 into 360 plus. Then we travel by how much?
90 plus alpha.
90 plus alpha.
90 plus. Correct. Very good. This is called theta, which is how much? 360 into 3 is 1080, I think. Correct. And then 1080 plus 90 is how much? 1170, I think.
Yes, sir.
Plus something which I don't know. So I'm just calling it alpha. Let's call it degree. Okay. So angle, if you make multiple rotation, then you will land in some quadrant. Okay. So no matter how big the angle is, you will always find yourself in which quadrant? Out of any 4 quadrant, right? First, second, third, fourth. So no matter what angle we represent, we cannot go beyond these 4 quadrants. So therefore, depending on where we land in the quadrant, we have the sign convention. So quickly, I will mention this. So what is the convention? This is called the first quadrant. And we always name the quadrant as per the rotation in anti-clockwise. So we have first quadrant, second quadrant. I am taking this as X, positive X. This is the third quadrant, and this is the fourth quadrant. So in the first quadrant, every trigonometric ratio, if you measure, will be giving you positive answer. So all positive. So what about the second quadrant? Tell me. In second quadrant, which ratios are positive and which ratios are negative? So I'll mention only the positive value, rest are negative. So the sine and cosec, the inverse, these two are positive. Every other ratio will be negative. So cos, cot, tan, sec, everything is negative except the sine and its inverse. These two are positive. Okay. So what about the third quadrant? So the answer is tan and cot. The tan and its inverse are positive, or everything else is negative. And what about the fourth quadrant? What is left now?
Cos.
So cos and sec theta will be positive and everything else will be negative. Okay. Now the question is how to do the reverse process, like how to get the angle or the answer. So we have some complementary rule, we have some supplementary rule, then we have the general rule. So I'll teach you all 3 separately so that you can be at ease in different situations. So we have the complementary rule. Sine of 90 minus theta we write as cos of theta. Okay. And cos of 90 minus theta is what? Sine of theta. So you can imagine theta as some angle. So 90 minus theta represents what? Of course, I'm writing here in degree. So when I write like this, I'm actually writing degree. So it is just convenient. So 90 minus theta is cos theta. 90 minus cos 90 minus theta is sin theta. So similarly, I can remove this degree. So we can add tan of 90 minus theta will be what? Now, what we are writing here is complementary value. So what is the complementary of tan? See, there are difference. You may get confused. Inverse and complementary are different, and it may be same. Sometimes it may be different. So the RNA is for tan. The inverse and complementary both are same. Cot. So cot is complementary also, and cot is inverse also. But for cos, complementary is sine. What is inverse? What is the inverse for the cos value?
Sec.
Sec. So you need to understand that, okay, the inverse and complementary are not always same. It may be different. All right. So the complementary rules are like this. I can just start for the other. So what about the cosec 90 minus theta? Okay, we are writing the complementary rules. So what is the complementary of cosec?
Sir,
Oh,
sec.
nice. It is written here only, no? Sec. Okay. So the sec of 90 minus theta. Cos theta. Anything left? Sine, cos, and then cot. Okay, so this is simple. The complementary rule will come with the plus sign also. So here you have to be careful. Okay, now the answer is very simple. Don't worry at all. Now you can just write the answer the way you wrote earlier. So just write the answer cos, sine, cot, sec, cosec, and tan. But you have to now remember the rule. 90 plus theta refers to what? Which quadrant?
Second quadrant.
Second. So in second quadrant, who are positive?
Sine and cosec.
So sine will be positive. This answer must be positive because sine is positive. And the cos. Everything also is will be negative. Simple. In second quadrant, except sine and cosec, everything else must be negative. So we must write the complementary rule, and we change the sign if you are negative in that quadrant. Okay. And always remember, we don't see right side, we see left side. That what is the sign of cos in the second quadrant? That is how we read. So when it is 90 plus theta, you just write the rule, the complementary rule. But now you check the sign convention and put plus minus accordingly. Okay. I hope this is clear. And now comes the supplementary rule. I hope you can do this very easily. So what is the supplementary rule? Supplementary rule is really nice. And why I'm saying it's really nice. In supplementary rule, we use 180 minus theta. And the best thing about the supplementary rule is the sine remains sine, the cos remains cos, and the tan remains tan. So on the right hand side, when it is supplementary rule, the sine, cos, tan will remain what they are. The cosec, cot, sec will be remain same what they are. Nothing will change. So cosec is cosec. sec is sec. All are very simple. Cot is cot. The only difference is the sign. Again, so you know the quadrant rule. 180 minus theta. Which quadrant it represents? Can you guess?
Second.
Second quadrant. So we think this way. 180 means you are on the left side and then you turn back a bit, so you are in the second quadrant. In second quadrant, what are positive? Sine and cosec, and therefore everything else will be negative. Correct? Is this clear? No. So it's very simple. For supplementary rule, what we do? We don't change the name. Sine remains sine, cos remains cos, sine, tan, cosec, cot, sec. The only difference is what we know the convention, we just put the plus minus. So it's pretty easy. So if someone is asking you what is, let's say, tan 135. So because it's more than 90, I can use the supplementary rule. I can also use the complementary rule. It really doesn't matter. So as per the supplementary rule, what we can write this as 180 minus what?
45.
And as per the rule, what is the answer? Tan 45. 180 minus theta is tan theta. But in second quadrant, tan is what? Plus or minus?
Negative.
Negative.
That's the answer. -1. Fair enough. Are you getting this idea? This is simple. If you're finding it difficult, just let me know. This should not be difficult. So what we do is we simply write the answer and then we check the sign separately and we assign plus minus automatically. And that's the natural way. Let's say if you want to use the complementary rule to solve the same. So this is also 90 plus 45. In any way, you will land in the second quadrant, right? So 90 plus tan complementary will become cot. And in the second is negative, so we'll put minus. But fortunately, cot 45 is also 1. So this is again -1. Let's take some other value just for your practice. Or if you're okay, then we can move ahead. Yes. So let's say someone is asking what is the value of cos 120. So choose the complementary rule or the supplementary rule and tell me the answer. So as per the complementary rule, what we should write here? Complementary means 90. But because it is less than 180, so I can use complementary. 90 plus how much?
30.
And as per the supplementary rule, cos of 180. Tell me guys, what should I write here?
60.
And in complementary rule, cos becomes its complement. Sine. And in supplementary, cos remains cos, isn't it? But 120 is what? Which quadrant? 120 is which quadrant, guys?
Second.
And in the second quadrant, cos is?
Negative.
And you can check both answers same. Cos 60 is half. Sin 30 is half. We know the answer. Yes or no? Hello.
Yes.
Okay. It's not difficult. I mean, if someone is asking you, you can answer this mentally. What is 135? So sine in the second is positive, so I am going to get a positive answer. And 135 is 90 plus 45, so it's going to be 45. Sine 45 is done. What is the answer? Is it difficult? And but if I ask you what is cos 135, you can get the answer rightly. Because it is bound to be negative, no? Which quadrant? Second. Hello. Is this clear? Okay.
Yes.
Now, something really interesting. Cos of minus theta. Can you guess which quadrant? If you remember the sign convention I taught you in vector, minus angle means how you turn.
So clockwise, we turn clockwise.
So if you turn clockwise by some value, you will land in which quadrant?
Fourth,
Fourth.
In the fourth quadrant, cos is
positive.
Positive.
That's why this is same as cos theta. And in the fourth quadrant, because cos and sec are positive, that's why they give positive answer. But anything else will give you negative answer. So what is sine of minus theta?
Minus.
Minus theta. So except cos or sec, the minus will always give you minus outside. So if I ask you what is tan of minus theta, the answer is minus tan theta. Do you realize this? Maybe. Yes or no?
Yeah.
Is this clear, guys? How we are getting the idea, the answer? So the rotation, the minus is telling you the rotation. You are going clockwise and something like this. So when I write 180 minus theta, it is same as 180 plus minus theta, which means you turn first anti-clockwise by 180, then you reverse by some value theta. That's the meaning of pi minus theta, correct? So you are here somewhere here. That's the answer. This is pi minus theta. You can interpret as a rotation. So you turn anti-clockwise, you come back. So minus means you turn clockwise. Okay. Anyway. So now, of course, having these rules in place, I can generalize these rules further. The last is like, now it's pretty obvious. 180 plus theta. Come on, guys, tell me. It's again supplementary rule. In supplementary, what happens? The sign remains sine, cos, cos, tan, tan, cot, cot, sec, sec, cosec, cosec, anything. So I can say any ratio 180 plus theta will be same ratio of theta with plus minus sign, which we decide with the help of quadrant. So 180 plus theta, which quadrant, guys?
Third,
And in third, what are positive?
tan is positive.
So I can say tan of 180 plus theta is tan theta. And so the cot, which is inverse, and luckily complementary also, I mean, there's so much luck, is same as cot theta. Rest negative. Do I need to write? It's okay. Okay, not okay. Should I write all the rest of the ratios also?
It's okay, this way.
I hope you will remember this. So, okay, I'll just write one. Sine of 180 plus theta. Which quadrant? Third. Sine is negative, isn't it? In the third quadrant, sine is negative. So sine 180 plus theta is minus sine theta. But sine 180 minus theta is plus sine theta. Okay. Tell me, guys, yes or no? Are you getting it?
Yes.
Yes, sir.
And the last, in general, let's say if I give you any random angle, any angle. So if any angle theta can be expressed as 90 into some number, some integer, plus minus alpha, then the ratio how we write, I mean, there is a rule for it. If n is odd, use complementary rule, complementary, or like this. If n is odd, convert trigonometric ratios into its complementary value. If n is even, don't convert. Trig ratio. That's it. Very simple. And what about the rest? The rest is simple. You have to actually check the quadrant, like which quadrant it falls, and then write plus minus accordingly, and then alpha will be alpha. So what does it mean is any ratio of 90 n plus minus alpha will be R complementary alpha with some plus minus sign if n is odd. I'm trying to create some sort of mathematical formula. And if a ratio of 90 n plus minus alpha will be some plus minus ratio of alpha, like I'm not taking the complementary, n is even, where RC represents complementary value. See, this is how we develop mathematics, right? We always, we create literature and we create symbols which is convenient to us. So right now you're following others' literature, but if you do research in mathematics, you will have the chance to create your own symbol to create your own mathematics. And that's the beauty of mathematics. Every mathematician had the liberty and they created their own symbol and notation. And so it was very easy for them because this is what they created. Okay. So you always think math as a literature. Math is never it is of course a less of a science, but more of a literature. So most of the mathematicians are very good poet, and yeah, most of them, because they know literature very well. Okay, so I'll just give you any question just for practice. Let's say if someone is asking you sine of, create some random value quickly. Find the value of sine of 1215 degree. So try it once, then I'll solve. I'm giving you 2 minutes. Got the answer?
Yes, sir.
Yes.
So what's the answer?
1/2.
Yes, sir. 1/2.
1/2 plus or minus?
Plus.
I think that's right. Okay, so if you use the 90 relation, if you divide by 90, what will you get? This is actually equals to 19 to 13 plus 45.
Yeah.
And therefore, if you put sine, this number is odd, so I can make it complementary. So I can add cos of the angle after this number, alpha, 45. And then I will check for the quadrant. Which quadrant? So I will again 90 into 13 is like 180 into I will divide by 4 actually. So one rotation is 4 times of 90. So 4, 8, 12. 13 is here. And then something. So which quadrant we land? Second quadrant, and in second we know sign is positive. So that's positive answer. Anyone who has not understood this part, please do ask. Rugved, you got it?
Yes, sir.
Shreya, you got it? No, she is not there. Tanish, you got it?
Yes.
So this is simple. Like any angle you can find, right? There won't be any difficulty. Just make this as a rule that 90 into odd number plus minus something is going to be complementary. And based on the quadrant, you can just use a sign convention. And then quadrant you have to check on your own. You know how to check. Okay, so after this angle and all, now we are good to go with trigo now. We have done the basic of trigo. So now we have the compound angle formula and so many things. So anyone who has to go now, like for some other lecture? Anyone who has to go actually right now?
No, sir.
Okay, very. So can we extend for some time if you're okay?
Yeah.
So now comes the something called compound angle relation. Compound angle. And what is this simple? I mean, it's like if given two angle or given a big angle, I can break into two small angles and then I can use the compound angle formula to get the answer. So let's say A and B, let A and B are two angles. And I want to know the ratio of the sum of two angles. Like I'm interested in finding out the sum sine of, like which is the ratio of sum of the two angles. A and B. What is the ratio of sum of angle A and B? That's a way to read it. Sine of A plus B. How we read? Sine of A plus B. So that's why this is called the compound angle formula. And this turns out to be really simple. So this you can write as sine of the first angle, cos of the second, cos of the first into sine of the second. Oh, that's fair enough. Easy to remember, right? It's like a rhythm. Sine of 1, cos of 2 plus cos of 2, cos of 1 plus sine of into sine of 2. Simple enough. We can prove it also. It's not a bit difficult. Have you seen the proof? So let's say we have one angle this. So I have this triangle. I will say this angle as A. And the other angle is B, which is something like this. I'll tell you how to do this. I'll make it bigger like this. And this is B angle. And therefore, I can always draw a perpendicular from the bigger line to this line. Okay, I'll do this. This will be better for me. Let me remove everything. So how we solve this question is you draw a line. So you simply do a right angle triangle, just a right angle triangle. And you can call this angle as A. And taking the hypotenuse of the first triangle as the base, draw another right angle triangle. And let's call this as B. And now to capture the essence of such a triangle, you draw a envelope triangle, like something like this. There's a mismatch for us. Oh, I'll do separately. Because there's a mismatch, I'll do a separate envelope like this. Okay, so now this is a triangle. And what we're looking for? We're looking for sine of A plus B. So if I just name it O, A, B, C, D, anything else? That's sufficient. So what is sine of A plus B? You can see clearly it's CA plus CA upon OD, correct? I can draw a line like this. And this is the simple right angle triangle because this length, let's call it D. So D is same as CA, right? The D to E ratio length is same as C to A, isn't it? Tell me guys, yes or no?
Yeah.
Now, first of all, I'll tell you how to solve this. This is pretty easy. This is A, this is 90. Can you tell me what is this angle? Can you guess? You can guess what is that? This is A, this is 90, this is 90 minus A. This is 90, this is again A actually. Understood?
Yes,
That
sir.
is A. So I'll just solve this. Pretty easy, it's very easy. So the simple rule of getting every answer is assume the biggest side as 1. Let's say this is 1. So if this is 1, what is the length of the base? We know the projection rule. 1 cos B. So can we say OB is equals to 1 cos B? Yes or no?
Yeah.
So we are going to play with the projection. If this is 1 cos B. And so this length will be how much? The DB will be how much? 1 sin B. Yes or no?
Yeah.
Now we'll take the projection of projection. So if sin DB is a hypotenuse of a small triangle DCB, what is the projection of sin B onto this base here? So I want to know this projection on this line. And we know the projection formula. This into cos of A. This into cos of A, no? This length is how much?
1 sin B cos A.
Correct. 1 is like nothing, so you can just say sin B cos A. Correct? So we got this length. Then very easy. It's very easy. Now you know the answer. Similarly, this is cos B. So this will be how much? Tell me. Can you guess? This will be how much? It is the projection of cos B, 1 cos B. Yes or no?
One
So
cos.
this is the projection of 1 cos B cos A. Just projection. You have to think about projection. And you're done. And what is the projection of here? Of 1 cos B? 1 cos B.
Cos B sin A.
Very good. Simple enough. And what is the DC value? What is this projection? In the small triangle, because we know this is sin B. This will be sin B of 1 sin B of sin A. Do you see that? Yes or no? So how many of you are able to understand this projection part? Because this is how we play with projection. Anyone who has understood?
Yeah.
All right. Rugved, you are not getting it. Huh?
No, sir, I understood.
Very good. So if you can draw this simple diagram, like I draw a square kind of thing, any ratio you can get from here without, okay, of course, worrying about the formula. So what is projection is a very powerful method. It gives you the shadow, play with the shadows. And you have to do this mastery that take shadow of this into that, into that, and so on. So, okay, sine of A plus B, which triangle will give me this ratio? ODE. In triangle ODE, can we write like this? Yes or no, guys? I think I can replace this by this. So in triangle ODE, sine of the angle is equals to the perpendicular upon hypotenuse. And what is the perpendicular? Can you see the perpendicular value from the diagram? What is DE, guys? Tell me, what is DE?
That's sine of A plus B. So DE.
DE. What is the D to E length? You have to add this value, no? Add these two to get the net
Actually, I
length.
was saying from the triangle OD. I mean,
Yeah.
the total angle subtended is A plus B, and the hypotenuse
So
is 1.
that is what we're trying to find. No? So what is sine of A plus B? So answer is DE upon OD.
Yeah.
And DE we can attach sine A cos B plus cos A sine B upon 1.
Yes, sir.
So we got the answer. Now what is sine of A plus B? Sine A cos B plus cos A sine B. Okay. And now you tell me, what is the, you can get all answer from here. What is cos of A plus B? Who will tell me the answer? What is the cos of value in the same triangle?
OE divided by OD.
Which is same as OE because OD is anyway 1. Hmm? What is OE? Can you get the OE value?
Cos B cos A minus sin B sin A.
Very good. So you know the answer, cos A cos B minus sin A sin B, right?
Yeah.
Now I'll tell you the intuition part, how to develop intuition. Okay. In the cosine compound relation, the cluster of sine and cos you will see, like you will see all sine term together, all cos term together. In the sine relation, they always come intermingled. Sine and cos will be weaved together, And that is how we remember that which formula it belongs to. So when you say sin A, sin B, cos A, cos B, or whatever, you can clearly understand it must be coming from sine. The moment you see that sine, cos, cos, sine, it must be coming from the sine formula. I hope this is okay. So
Yeah.
cos of A plus B is cos A cos B minus sin A sin B. And you can see the minus is logical. And if you can remember this diagram in your brain again, you can see it is going to be the minus will come. So the other logic I can give you is, the other logic is easy to remember. The cos is a function in which as the angle will grow, you will get lesser value, isn't it? If you remember, cos 0 is 1, but cos 90 is 0, right?
Yeah.
Which means a bigger of the cos of bigger values gives you less value, right? Cos 0 is maximum, right? Isn't it?
Yeah.
Cos 0 is maximum. Therefore, as the angle will grow, it will give you lesser value. So minus is obvious. So cos of A plus B is going to be less value. And so the minus sign. You can remember this way, just to create intuition. But sine will grow with the angle. So when you have more angle getting added together, you'll get more values. Okay. So sine of A plus B is sine A cos B plus cos A sin B. But in the cos formula, the plus will bring minus in between. Okay. All right. Similarly, you can tell me what is the value of tan A plus B? That's the last definition. What is tan A plus B? Tell me. Please quickly. Same triangle. You can use the same triangle.
DE upon OE. So sin A cos B plus cos A
The
sin B.
tan, yeah, tan is always the ratio of sine upon cos. This we have to always use it. So for finding the tan, it's a very, yeah, of course you can see that triangle. But what I'm saying is, the moment you know the sine and cos, you can take the ratio, you get the tan. Okay. So we should use always this relation. So tan of theta is always sine of theta upon cos of theta. So what is the answer now? So both answers are ready with us. So sine A cos B plus cos A sin B upon. And don't try to mug up. Try to realize that what should be the answer. What is cos A plus B? Cos will come together. Cos A cos B plus or minus
Minus.
Minus.
sin A sin B. And how to remember? In cosine formula, sine comes with sine, cos comes with cos. Okay. But this is not a nice way of writing because I want the answer in terms of tan. So how to convert this formula into tan formula? So what we do? We simply divide by cos A cos B in the numerator and the denominator. So tan A plus B is equals to sin A cos B plus cos A sin B upon cos A cos B minus sin A sin B. And this we can rewrite as sin A cos B plus cos A sin B cos A cos B minus sin A sin B. Oh my God, so much writing. And then what we do is we divide the numerator and the denominator by cos A cos B. and this will simplify the answer. So if you divide each term separately, the first term will cancel cos b. What will left with? Tan sin a upon cos a. What you can write?
Tan A.
Tan a plus tan b. You can see upon 1 minus tan a tan b, right?
Yes, sir.
It's simple enough. These are not difficult at all. Again, if you want to master trigo, you have to keep on writing, keep on practicing. You have to manipulate the things like this: divide, multiply, and do something. So SL1 is really good. I mean, the first initial 5-10 chapters, it's so easy. You can go on your own. Like I have given you all the basic, and you will be able to solve entire question, every question. It's so easy. So Trigo is all about manipulation, like how you take the ratio, which ratio, that ratio, and it's like only manipulation. Okay. So now having all the three formula, we can actually create infinite formula. So we have like a double angle formula, half angle formula, and so on and so on. So what is a double angle formula? Double angle. You know the a plus b. If I replace b by a, what will happen? All term become double. Sine 2a, cos 2a, tan 2a. So to create the double angle formula, we can again use the compound angle formula. So compound angle is the basis for all the other derivation. Okay. So let's say if I want to know what is sine 2a, you use the compound formula a plus a. And you can think one term as a, other as b. How to write the sine a plus b formula? Sine a cos b. Oh, yeah, a. But b is a here. So sine a cos b, which is sine a cos a, plus cos a sine b, which is again the same answer. Do you realize this? Yes or no?
Yeah.
Or in the compound formula, if you substitute b by a, what you will get? You will get the same answer. So sine of 2a is how much? Twice of sine a cos a. Now that's called the formula. I mean, it's really simple. So sine of double angle is what? 2 times sine of the angle into cos of the angle. Are you getting it? Yes or no? No. Yes. Don't know. Confused. Is this clear, guys? Hello, hello, hello.
Yes, sir.
So now similarly, if I ask you, what is the cos of 2a formula? The double angle, the cos of 2a. It is same as cos a plus b. Correct? So what we can write?
Cos A minus sin A.
Very good. So it's cos a minus sin a, which means
Cos
cos square a minus sin square a. Pretty simple formula. And it's very interesting that the difference of the square is cos of double angle. Oh my God, that's very interesting. And let me give you, let's say, how to play the trick. So someone will give you a question like this. Find the value of cos square 15 minus sin square 15. You get scared. Oh my God, I can't solve this. 15, even we don't know what the answer. But now this will tell you, oh, this is simple. This is cos 30. The double angle formula, right? And therefore this is known to us. Now this is a simple question. Manipulation is important, and therefore you need to know all formulas in Trigo. So what I'll suggest is that to derive everything twice, thrice at home, like although I have written here, but that is not of any use for you. You go at home, draw those triangles, try those manipulation, take the projection, and feel for yourself. When you feel it, a lot things will become simplified in learning process. And again, I'm not teaching only for physics. It will tremendously help you in mathematics. Okay. And the last formula which I will stop today with, tan 2a, tan a plus 1 minus tan a tan. Huh? So how to write this? Tan a plus tan a upon 1 minus tan a tan a. Do you realize this?
Yeah.
Yes, sir.
Which is simply 2 tan a upon 1 minus tan square a. Okay. So you have to play with all these ideas of trigo is something like a lot of equation which you will see can be solved with the help of trigo with ease. Okay. So trigo is a powerful tool actually, and learning trigo in the very beginning is super beneficial. And also calculus. I mean, normally, see, the entire education system is collapsed in any way. I don't know how they have designed the entire syllabus. They teach calculus at the end of the maths. And of course, I mean, there's a reason for it because to understand calculus, you need to know trigo, algebra, and other things, but not that much. So for me, the calculus should be brought in the very beginning of the course. And it should be brought in two phases. One, the you can say beginner level to the moderate level, and then advanced level at the end of the course. When you have learned everything, then see the advanced part. And that is the reason, like most of us struggle in learning physics in the beginning. By the time you come to class 12, you get a bit comfortable. I never struggled. The reason was simple. In my time, the learning process was totally different. All the syllabus was the same, but we used to study calculus first. Most of the coaching institutes in that time, they should teach the same way. They always start with the calculus, and then they used to go back with other. The reason was trigo was something that was part of class 10 syllabus, so we were knowing trigo anyway. For you guys, it's difficult because you have not learned a lot of trigo in class 10, very basic one. So what I'll say is that for next 1 month, I'm saying 1 month, you devote yourself for trigo, and in that way you can finish the trigo part of maths, and then come back to other topic of mathematics. Okay. So anyway, this is the beginning. Next lecture, I'll give you some more interesting formula and the application, of course, because only with formula you will not do anything. Just I have shown you one application, but I will suggest that okay, you can start now going through the Lonely textbook. If you don't have, please do purchase. It's very cheaply available at a cost of hardly 70 to 80 rupees. Thin book, and exercises are very small, like 20 questions or 30 questions per chapter. But it's good to start with. Okay.
So this book is for trigonometry, huh?
Yeah, only trigo. Only
Okay.
Loni comes for trigo and coordinate geometry and statistics. Statistics separately. So you can buy the trigo, and you can also buy coordinate geometry. It's all are 50, 60 rupees price and on Amazon actually. And offline, if you get on like old bookshop, 20 rupees, maybe they'll give you 20 rupees. It's good to buy new. That's not very expensive. But keep these two books at home. That's very important. And start solving from today. So you can start solving trigo from today onwards. I can guarantee you will be able to solve almost 70% of trigo from Loni once I will finish the entire chapter. Okay. And do derive these things. Okay. I mean, you have to derive, you have to realize, you have to derive. If you not derive, you will never realize. it's always easy. These formulas will settle in your brain one by one, and then only you can use it. Okay. So all right, guys, bye and take care, and I'll see you on Friday. So on Friday, for first few weeks, I'll continue with maths only, because until I'm not reaching the calculus part, I cannot start kinematics. So once I'm about to touch the calculus, I'll start kinematics together, and it will now run parallelly. Okay. So it will not take much time. I think after 3 lectures, we should be at calculus, because I will take a lot of time in calculus. I will teach you almost calculus again. And the amount of calculus that I will teach you will be sufficient to solve NCERT mathematics till JEE-Mains level. Okay. Beyond that, you have to study maths, which is having advanced part, which I don't cover. All right. Bye and take care.
Thank you, sir.